Welcome back. In our last session, we were discussing about developing the decision tree for a particular type of situation where we had the problem of developing the decision for our warehousing requirements. Three alternatives were there and we developed the complete decision tree which is there now for the ready reference of us, and this type of decision tree we finally developed in our last session, that the initial demand was 100 units, the initial price in the spot market was $1.2 per square feet, and chances of increasing the demand are 20%, chances of decreasing the demand are 20%, chances of increasing the price is 10%, and chances of decreasing the price is also 10%. And increasing the demand and increasing the price means the uncertainties of demand and uncertainties of the price are independent. So, I cannot say that by change of price demand is going to affect, or by change of demand price is going to be affected. So, these two things are independent, and therefore, the probabilities of 0.25, 0.25, 0.25 and 0.25 are there for combined effect of change in demand and change in price, and therefore, this type of decision tree is available in front of us. Now, when this decision tree was developed, after that we need to see that what are the three alternatives which are there in front of us. So, the first alternative is that we can take all the requirement, we can take all the space from the spot market, and for that purpose in the spot market we did this type of calculation, that for a particular situation where demand is 144 and the stock market price is 1.45. So, the total cost of this type of decision where my price is 1.45 and demand is 144,000 units. So, we calculated in the last session, if you remember, that total cost of space, because I am taking 100% from spot market. Since I am taking 100% from the spot market, so the cost will become multiplication of this, and this is the price. So, the multiplication of these two things, and then the second thing I need to calculate revenue from selling these units. So, I will be selling because I am fulfilling the entire demand. So, revenue will be the cost, the selling price that is given to us as 1.22 and into the demand, and then we will calculate the profit, that is revenue minus cost. This is revenue minus cost, and in this calculation with this data we got the value that is coming minus $33,120. This is minus 33,120. In fact, this minus sign signifies that it is a loss. If this type of situation comes where demand increases from original 100 to 144 units, price increases from 1.20 to 1.45, and we are fulfilling our total requirement from the spot market. So, we are going to get this is negative, it means this is the loss we are going to have. Now, we need to see from this particular case, this is the value we got from period 2 and with this type of state. Now, we as discussed in the previous sessions, from this we will go to time t0. We will go to time t0, and for that purpose, from this state I will come to this state, and let us see how do we come to that period 1. Now, expected profit at each node in period 1 is the profit during period 1 plus the present value of the expected profit in the period 2. Now, when I am talking of period 1 and this is one node, so the profit at this, when I am trying to determine, so what is the actual profit because of these things, 120 and 1.32 is the spot market price, and the present value of various expected profits which are coming from this state. So, from this state there are 4 states which are coming, and these 4 states have the possibility of 25% each. So, I will see the possibility of getting this negative profit, possibility of this loss of 33,120 is 25% in period 2. Similarly, with respect to 144 and price 1.19, I will calculate the profit. With D equals to 96, profit price 1.45, I will calculate the profit, and the other state is D96 and price is 1.19, I will calculate the profit. And for all these profits, the probability, the possibility is 0.25, and that will be the expected profit at period 2 emerging from period 1. And then that total, I will calculate the present value of that total for period 1. So, that all calculation we will discuss. So, this is what I mentioned in the first point, that expected profit at each node in period 1 is the profit during period 1 plus the present value of the expected profit in period 2. Now, expected profit EP, that is D and P at a particular state 1, comma 1 means at time period 1, and for a particular level of demand and at a particular level of price. So, when D is 120, price is also 1.32, that is the first state. If you go back to your notebooks and see the decision diagram, at a node is the expected profit over all 4 nodes in period 2 that may result from this node, that we already explained. Then present value of expected profit. The next thing is present value of expected profit. In our some earlier session, we have discussed about the time value of money concept, and with the help of that time value of money concept, we understood that whatever is the future streams of cash flow, you need to calculate the present value of those future cash flows, and for that purpose we use the discounting rates, and in this example we have taken K equals to 10%, because we are going to calculate finally at time t0. So, we need to determine that this is possible after time t2, and what will be the value of this in the present circumstances, and for that purpose the present value concept is required. So, present value of expected profit is the present value of this expected profit, and the total expected profit is the sum of the profit in period 1 and the present value of the expected profit in period 2. So, this is about at time period 1. Now, just to see the calculation, that how this expected profit calculation has taken place, For that purpose, you see, from node D equals to 120, and to have a better understanding, we have this diagram here. Let us go back to that diagram and quickly let us have that diagram on the board, so that you can easily see that how things are moving. This is D equals to 120 and P equals to initially 1.20. Then you have 4 possibilities, and let me discuss this only, where the D is increasing to, this was initially the 100 and then it become 120. Price was initially 1.20, then it becomes 1.32, and then there are further 4 possibilities, and these are 144, D is 144 and P is 1.45. The next is D is 144 and price has decreased, it becomes 1.19. Then demand decreases, it becomes 96, but price increases, it becomes 1.45. And then finally you have where demand also decreases and price also decreases, that is 1.19. So these are different alternatives which are emerging out of our tree. Now, for the purpose of calculation of profit at our state 1, period 1, this state 1, period 1, here our demand is 120, price is 1.32, and there are 4 alternatives as shown on the board. Now we will evaluate the expected profit in the period 2 over all 4 states possible from this. So like this, we have calculated the profit for the first case where it is minus 33,120. Similarly, you need to calculate the profit for this state also, for this state also, for this state also. So that is what we have written here, that 0.25, and for the situation of D144 1.19, D96 1.45 and D96 1.19. So these all are the 4 different states, and then the expected profit is multiplied by the respective transition probabilities, that is 0.25. So that is the expected profit for all these things. Now when you have the calculation, so these values are coming like that. Here it is coming 4,320, this value is coming minus 22,080, and this value is coming 2,880, and the probabilities are same, 0.25 for all these different states. So the total expected profit is the sum of multiplying of these probability with these profits. So you need to get the sigma of probability multiplied by the profits. That sigma is the total expected profit for all these states. So that comes to be minus 12,000. This is minus 12,000, that is the expected profit at period 2 from D equals to 120 and P equals to 1.32, that is state number 1 in period 1. Now the second thing is, once we have calculated this expected profit of minus 12,000, this expected profit of minus 12,000, we need to calculate the present value. The meaning is that this expected profit is in period 2. This expected profit you will get in period 2. Now, presently I am talking of period 1. So, the present value of this expected profit, so I will add present value of expected profit, this fraction, and then this present value of expected profit is expected profit multiplied by discounting factor, and discount factor is represented by k in our case. So, it is 1 plus 1k that is to be divided by. So, this expected profit comes here and it is to be divided by 1 plus k. Seeing that this is the present value of your expected profit, which is expected profit divided by the discounting factor, and as we can see now that for period 1 for which we are talking, where demand is 120 and the current price is 1.32, the expected profit, the present value of the expected profit is coming to be 10,909. The 12,000 was the expected profit for this data, and this is divided by 1.1, that is coming to be 10,909. So, now the total expected profit, for this node where demand is 120, price is 1.32 at state 1, is the sum of profit in period 1 at this node plus the present value of the future expected profits possible from this node. So, this is the present value of the future cash flows, and what it is going to have on its own in this particular period. So, that is coming to be here. So, now in this period 1, the demand is 120, the price is 1.32. So, using the same formula here, the profit here will come, because I am going to fulfill the entire demand. So, 1.32 is the cost price and the revenue is 1.22. So, this is coming to be minus 0.10, and therefore, this is also coming to be the loss in this particular case. So, that is what shown here, that 120,000 into 1.22 is the revenue factor, 120 into 1.32 is the cost factor. So, revenue minus cost is the profit coming in the period 1 plus the expected profit and its present value. So, that is present value of expected profit, that is, so this entire value, this is coming minus 12,000 and this is coming minus 10,909. So, the total profit, the total expected profit at node 1 of state 1 is minus 22,909. This is the total profit here. Total expected profit here is coming to be minus 22,909, which includes the profit generated at this time plus the present value of profits from all these future states. So, that is taken care. And now, you already can understand that similar calculation will flow to period T0 also. The same calculation will come to this state also, because this state is coming from this state when the initial demand was 0 and P was 1.20. So, now when I want to calculate the total expected profit at T0, when I want to calculate the total expected profit at T0, I need to calculate the total expected profit for all the 4 states, because this node is giving rise to 4 different nodes. There are 4 different nodes, and in our last session we already have discussed what are those 4 different nodes. So, I will do the same level of calculation of determining the total expected profit for all these 4 nodes. Different values will come, and then the expected profit for this particular node will be the multiplication of this expected profit into the transition probabilities, that is 0.25 for each of them, and then I will calculate the present value for period 0. So, that becomes the present value of expected profit, and then I will also calculate the profit coming from this particular node in the original period, and that is the total profit, total expected profit for this particular option when I am going for 100% spot market. So, let us see that what type of table emerges, because it is a quite lengthy calculation, and therefore, it is not very much advisable to show the complete calculation of developing the table on the board. So, let us see on this slides that how the table emerges. So, for period T, for period 0, the starting period, the total profit for the original state, that is 100 unit is the demand and the initial price was 1.20, is the sum of the profit in period 0 and the present value of the expected profit over the 4 nodes of time period 1. And this is how 0.25 into the profit of this plus this plus this plus this is becoming the total profit, and therefore, you have the calculation of minus 22,909 for the first state, but for the remaining states you have these calculations 32,000, 15,000, then 21,000, and like this final calculation becomes 3,818. That is the expected profit during time period 1. That is the expected profit during the time period 1. But for time period 0, I need to have the present value of this expected profit. I need to have the present value of this expected profit. So, I will divide this by this 3818 by the factor of present discounting factor, that is 1 plus k. So, this is 3818 divided by 1.1, it becomes 3471. So, what does it mean? That this is one part, this is only one part, that this is the present value of my all future cash inflows at time t0, but I also need to add into this, 3471 the value of profit or loss which I am incurring in this particular period. So, that is done in the next slide, where this 3471, this component is there from the future cash flows, and the present value of those future cash flow is 3471, and the present value of my profit is in the current period. I am selling 1.22 is the revenue, 1.20 is the original cost. So, it becomes 2000 rupees is the profit, $2,000. So, 2000 plus 3471. So, the total amount of profit which I am going to get is 5471. So, therefore, the expected net present value of using 100% spot market is 5471. This is the final calculation available to me. Now, using the same approach for lease arrangement. So, then when lease arrangement is there, in this case it is 100% spot market. Now, I want to go for the lease arrangement, thus I want to try for the second alternative, and when I am going for the second alternative, my net present value is coming 38,364. So that is the total profit which I am going to get in case of lease arrangement if I do a lease agreement for 100,000 units initially. And if I ignore the uncertainty, so for this type of issue, if you remember in our 3-4 sessions before, the net present value was coming to be 60,182. Let me take you to those slides where we ignore the uncertainties and we only consider the certainties, and only on the basis of time value of money we determined this case. So when we took that data into account, now in this particular case there was no uncertainty. Initially the rate is 1.22 and the rate of lease was $1 per square foot, and the profit was, annual profit was 22,000. And in this particular case the uncertainty was not there. So we were having a very fixed type of cash flows, and this case gave us the NPV equals to $60,182. So because uncertainty is there, so certainly because of these types of fluctuations in my pattern in my future, obviously I have to sacrifice on my profit, because I am not very sure that what may happen. So this 60,000 reduced to 38,364 when some kind of uncertainty I have built into my situation. But considering the situation of earlier case when I am going for the spot market, and in that spot market my profit was coming just 5,471. So that is much less as compared to 38,364, which is much higher. So even though uncertainty is there, but now we can see on this calculation basis no uncertainty. Obviously there was a clear choice that I will go for lease agreement. But even with the uncertainty, the kind of data which is there and kind of this calculation is showing to me that I should go with lease arrangement, because of and the size of the lease is 100,000 square feet. So this arrangement is very suitable because of higher profits as compared to the spot market. The third option now which we need to evaluate, that is flexibility. Now we want to actually, in this particular case the data was supporting the lease arrangement, but it is quite possible that in some cases lease arrangement may not be that much useful. So we want to have a combination of both these things. So we want to have some kind of flexibility in this particular case. And when we want to have flexibility, so you can see that the condition which we are developing is, so how we can use this decision tree method for evaluating the flexibility in the supply chain, because the whole predictive analytics, the whole real time data uses is to have flexibility in your supply chain. If you do not have flexibility in your supply chain, the issue of real time data uses will not going to give you any kind of benefit. So flexibility is a kind of you can say prerequisite for adopting predictive analytics, for adopting the real time decision making. If your supply chain, if your warehouse is a lease arrangement which is a specified space, so there is no point in getting this real time information, because in daily basis or a monthly basis or on annual basis you are not able to change the available space. So therefore the point is that in this particular case we need to see that we can use the available space on the flexible basis, and then only the usage is possible. Because why I am saying that? If you go to this particular example, and when you develop this type of calculation for the lease arrangement, because I am taking 100,000 area for my lease arrangement. So, in that case, when my demand is 144, when my demand is 120, these types of additional requirements I may not be able to fulfill, because my area is only 100,000. So, for 100,000 I will be fulfilling from my warehouse. The additional demand I will not be able to fulfill because I do not have space. The second issue is when I have the less demand, 96, when I have less demand, in that case also I will not be able to utilize my capacity to the optimum level. I have unused capacity, I am giving rent for no reason. I am giving rent for no reason. I have wasted my money for because my company is having a system of fulfilling all the demand. So, what will happen, that 100,000 I will fulfill from my warehouse, and the remaining 20, for that I will go to the spot market. Here 100 units I will fulfill from my warehouse, and for the remaining 44 I will go to the warehouse. So, this type of arrangement, when I am going for the lease kind of system, so this arrangement I have to follow, that a fixed amount I will use from my warehouse and the remaining I will use from the spot market. So, therefore, flexibility is advocated, where in some of the cases when you go to the continuously downward trend, like 100 is here, and if it is just 80% of the original demand, so it becomes 80, and then further in the next period it reduces to its 80%, so it is only 64. So, in that case you have 36,000 square feet of area which is unused. So, that is also a loss. So, therefore, we want to have flexibility in my supply chain which can give me the benefit of both these options. So, we stop here in this session, and in our next session we will see that how flexibility can be incorporated in uncertain environment, because that is the most important part where predictive analytics can help us, and we can minimize the cost of offering, and it will help us in increasing our revenue. Thank you very much.